Well, welcome everyone. I'm Stuart Bond. I'm VP Research at IDC, focused on data intelligence and data integration software. You are here for session 6D, metadata-driven data fabric, and it's being presented by Mayank Mehra. Did I say that correctly? And we have Sanjeev Mohan with us, and Milind Chitgupakar.
Correct.
Close?
Very
Correct?
close.
Okay, good, awesome. All right, quick bio. Mayank Mehra is an accomplished product management professional, currently leading the products team at Modak, a specialized firm that focuses on creating accelerators to automate and streamline data management activities for enterprises. In his role, Mayank oversees the product strategy, roadmap, and development initiatives to ensure alignment with the company's overall vision and objectives. There's a much longer bio here, but I'm going to cut it short in the interest of time, give these guys a chance to tell you more about what they're doing. Sanjeev is an established thought leader in the area of cloud, big data, and analytics. He researches and advises on changing trends and technologies in the modern cloud data architectures. He started his analytics journey at Oracle, where he worked on emerging technologies. Until recently, he was Gartner Vice President, known for his prolific and detailed research, and is for directing the data and analytics agenda. Now a principal at Sanjmo, he provides advisory and consulting services covering modern data stacks, quality, security, governance, observability, and operations. And I'd call him a competitor if I could, but I think he's more of a colleague.
Yes. Yes. A friend for life. Yeah.
And finally, Milind Chitgupakar is the co-founder of Chief Analytics Officer of Modak. I've already told you what Modak is. For more than 23 years, Milind has provided thought leadership and delivery excellence on several enterprise client engagements that involve business strategy, analytics, and modern data platforms on extremely large data volumes. With that, I will turn over to Mayank, or who's going first? Sanjeev is going first. All right. Just quick housekeeping. If anyone has their devices set to ring, not set to silent, please set them to silent so that we don't get any interruptions. That, over to you, Sanjeev.
Great. Thank you, Stuart. Stuart and I, this is the third time we are meeting this year?
Probably within 2 months, yeah.
And within 2 months, so so not a competitor. In fact, I'm just so happy to see all of you. I have people from my Gartner days by the way, I left Gartner 2 years and 1 day ago, and I started Sanjmo, and now I'm living the life of being an independent advisor, and I do a lot of fun stuff. So today I'm going to talk to you about data fabric. So let's look at a few things that we're going to talk about. Before we even go into agenda, just when this conference started, we did a poll on WOVA. How do you even say that? Yeah, WOVA. So we did a poll, and check this out. The top line, 51% of people are researching data fabric, and at the bottom line, 12% are asking, what the hell is a data fabric? So that's a whopping 63% people have no idea about data fabric and they're researching. So that's why it is so important. In fact, data fabric became popular when Gartner started talking about data fabric. In fact, before generative AI took all our attention away, it was all about data mesh on LinkedIn, and there was this massive war going on between Gartner and the rest of the world, data mesh versus data fabric. And then this year, Microsoft announced Microsoft Fabric. So data fabric is an important topic, and that is why today we're going to talk about different things. The first thing is start with why. Why do you need a data fabric? Then we will talk about what are the key components and the building blocks of data fabric, followed by how do you create a data product, and that is one of my favorite topics. In fact, I'm writing a book called Data Products for Dummies, which is coming out in September. So that's a very important topic. And then we are going to talk about Modak. In fact, what we decided was, instead of doing death by PowerPoint, we are going to do a fireside chat. And guess what? You are all invited to participate in the fireside chat. I know Mark's already getting ready with his questions. So he's going to bring out his ones, and then we will end up with key takeaways. So with that, I am going to get started. So I'm not going to do introductions. Stuart's already done that for us. Thank you, Stuart. So I want to talk about why. What is going on? So one of the beauty of what I do, and I work with a lot of you. I see the data whisperer is lurking in the back. If you don't know the data whisperer, so it's all about. So the very first bullet is it's all about business productivity. There are no technology projects. Technology is in existence to serve a business process. So, Milind, what are you seeing when it comes to?
So, thanks, Sanjeev. So when you look at when people are, and we primarily work with large enterprises, and I can give you that guidance of what happens with data products. Everybody, all different data domain leads and different departments, and everyone starts building their data products. And then how do they go about that? First, they do the data discovery. So they spend about a couple of weeks on data discovery. Then they go and say, hey, is this data sensitive? Or the data owner decides that I'm not going to give you access. So that takes another 1 month. Then you go and say, okay, we have these data products. Let me go and mark and put business glossary in. So that takes about a couple of weeks. And then you get to the sexy part, which is transforming data, creating some data products, and then publishing those data products. But if you look at the cycle, how do you scale up building data products at a scale? Like how do you do data products in a couple of sprints instead of like couple of months or 6 months or whatever that is? You see that we see a common pattern of repetitive behavior where people are doing the same activities over and over again. So one of the things which clearly Data Fabric helps is reduction of that undifferentiated heavy lifting, if I might put it that way. So reduction of that and focusing more on your business team and business product and data products. So that is why you need to consider Data Fabric, and how do you implement that at scale?
So what you're saying is that you are using Data Fabric to create data products.
Yes.
Okay. And what is a data product is something we'll come to in a few minutes, because there's a lot of confusion about data fabric, data products, data mesh, and so on. So we'll talk about data products a little bit more. The other thing that also changed in 2023, we went through this period of like in 2021 where money was no object and people were spending like on technology like it was going out of fashion, and then 2023 hit and everybody became conscious about spend. In fact, FinOps has become such an important topic. So one of the things that we also consider Data Fabric is to reduce the cloud cost. I'm going to turn to you once again. What do you see?
That's an interesting thought, because 80% of the questions we are getting at our booth are, hey, how do you help us reduce cloud cost? Because everybody's talking about the same thing, like reduction of cloud cost. But one of the things, again, like I said, repetitive activity, and every team goes and builds their own kind of architecture, their own kind of data platform. Somebody uses Databricks, somebody uses Cloudera, somebody uses Snowflake, but they go and build their own kind of siloed environment. And the first time you're doing it, obviously it's going to be unoptimized for cost, because you want to move fast, you build it, and you straight away build that, right? One of the key features of Data Fabric is, since we are taking out that repetitive work and heavy lifting, that becomes very optimized. So the enterprise IT probably takes care of that whole building of Data Fabric, and also your repetitive activity, like how do I discover my data? Do I have access to the data? How do I integrate the data? How do I move the data? How do I tag my data? How do I do my governance or de-identification of data? So all these activities are optimized for specific cloud, and that kind of reduces your cost. That's what we have seen at our clients. And then you focus on whatever tool you want and start building your data products. So still you do like 80% heavy lifting with an optimized standard process. 20% is how build your data products on whatever technology suits you best.
So you're saying you add a lot of automation of repeated processes.
Absolutely. That's to me is the key feature of a data fabric. Is like removal of repetitive activities, make them automated, make your data movement automated, make a lot of your augmentation as far as data processing and data preparation is concerned.
Right.
And then, okay, now that I have all, and the analogy I love to give is, think of a commercial kitchen. So what IT teams now are doing is they are building gourmet recipes at home. So they go do grocery shopping, which is like look at your data elements, go home and then start preparing some secret sauce or nice sauce and then prep that data, put a meal on the table. It is a heavy activity. It takes about 4 or 5 hours or 6 hours. If you go to commercial kitchen, you want the dish out in like 15 minutes to half an hour. So what do? They bring the veggies, they prep the veggies, they cut the veggies, the sauces are prepared beforehand, and that's your data fabric. So you are looking at a commercial kitchen model for your data fabric, right? And then now I roll out my data products as fast as a commercial kitchen.
You know, one of my favorite principles that I learned when I started looking into data fabric and all, something that even I try to apply in my personal life is a principle called DRY. Anyone has heard of DRY, D-R-Y? Do not repeat yourself. It's such a powerful thing. Why keep repeating, doing the same thing over and over? It's like that definition of insanity. So that's what data fabric is trying to do, is it's trying to abstract that repeated task. And you talked about data preparation and all. So we've talked about the problem statement. Let's look at the next slide, what are the building blocks? And do you want to talk about how do you go about building a data fabric?
Yeah. So if you look at like I said, the repetition of activities which you do, one is how do you discover data? So I want to find the data for this particular product or this particular customer or this particular area. So you spend a lot of time just discovering your own data. So how do we automate that using a knowledge graph where you ask the questions to the knowledge graph and then it comes back and says, hey, look, your data lies here. And these are the data sets you have. And not only does it tell you about what data sets they are, but it also gives you like this data set contains information on, let's say, a customer ID or a product ID, or it is intelligent enough to start tagging those elements for you in an automated fashion, right? So you first do your data discovery. And once you do the data discovery, now you said, okay, now I have this multitude of cloud applications or on-prem databases or your object stores or your file systems. Now with generative AI, you might want to mine your documents. So these are in different various formats. So how do I move the data to my processing environment? So that's a data movement activity. Once you have that, that can be structured data, that could be JSON data, that could be XML data, it could be just unstructured data which you're now gleaning out. So you need to glean that information out. So you have to prep the data, process the data, so that you need a set of tools for that. Then next step comes that I have done my building process for building data products. How do I then now put those into production? So you have doing data orchestration. That's not as easy because you now need to know about data quality. Like, hey, is there a schema drift somewhere, or do I have some data quality issues? Do I have some data observability which is going on? This pipeline which ran for 1 hour now runs in like 10 hours or whatever it is. So you need to continuously monitor those and then look at like optimizing those processes. Now, all of this need to talk to each other. These are distinct capabilities which enterprise already has. So this is like not new capabilities which we are talking about. But the problem is, how do you ensure that these capabilities are now talking to each other? So that's where the unified metadata comes in. And then all these capabilities are putting in the same metadata. And that's where you kind of have building blocks for your data fabric.
I might even have a slide for you on that, unified metadata. So this is a great point. In fact, in this conference where we've got more business people, more CDOs, so we are very focused on governance and security, privacy, all of these things. It is actually quite a contrast from some of the recent conferences I've been to. I went in 1 week, I crisscrossed between Snowflake Summit and the Databricks Summit the same week, and I ended up writing 2 blogs on my Medium site on what were the key findings. It was all about LLMs. So I feel strongly, although who knows next year how things will be, that some of the data quality problems, data observability, data discovery, can benefit quite a lot from some of these AI techniques.
Yes, absolutely.
Is that something you?
Yeah, we are also looking at that from mostly from a data discovery perspective.
Yeah.
So how do you use an LLM models and how do you train them? And the good news is the foundation models are there, whether it's BART or OpenAI or whatever it is. But how do you prepare your vector databases or you prepare LLMs and feed that and augment those models to answer what you want out of that?
I see.
So we are actively working on that aspect, especially for data discovery.
Right, because what happens is that traditionally we run SQL queries. SQL queries are great. They will give you the most accurate answer of what you ask, but it's a keyword search. So, but if you're looking for contextual semantic search, where things may not match, so like if you're doing discovery and there are two values that kind of mean the same thing, but they're different column names, then traditional approach may not even find that connection. But a semantic thing using vector search can find it, because that's what semantic model is supposed to do. It uses context. So there's a lot of power in using LLMs in future. I know we've overblown the whole LLM space. In fact, I did this slide yesterday. We had a tutorial on this topic. And one question that I get a lot of time is, yeah, but are LLMs accurate? No, they're not. It's a semantic search. And semantics change. If you want accurate search, then you do a keyword search. SQL is deterministic. AI is probabilistic. So if you know that difference, then life is good. But if you don't, then you're fighting it.
But
so
the problem there is a lot of people write to struggle, especially when you want a business interface. People write to struggle to write good SQL, especially data analysts or data people who are dealing with data. The good news with the ChatGPT 4 and the other thing is, I'm just awed by how powerful that is, that it even competes with the best SQL writer. So you provide it enough contextual information, it's able to build that SQL for you, grab that information. It's of course not accurate, but it's very, very close.
Yeah. So see, this is a really important point, Milind, that you make. There's a place in life for LLMs. It's not everything. There's a reason why LLMs are co-pilots and not pilots. Who's a pilot? You're the pilot. So you should treat LLM as a personal butler who's learned everything in Stack Overflow and can write amazing SQL, but it may not be correct. You still need to optimize it. But the point is that if your productivity has gone up by 80%, it's a win. And so the whole hallucination thing and all, by the way, that's not a bug, it's a feature. It is a feature. Because it is doing this semantic search. So that's how it's supposed to be. People may not like it and they may fight it, but it is a co-pilot. Anyway, I digress. So let's get back to our slide. Okay, my favorite topic is data products. So how many of you have heard of data products? Sure. Okay, so most of you. How many of you know exactly? Can you define what a data product is? Okay, so it's pretty much okay. So let me demystify what is a data product. There are two ways of looking at data product. There is a business and a technical. So we very quickly jump to technical, but let's talk about business first. We build data warehouses, data marts, and we've been doing it for a long time. Those are projects. Sometimes those projects run how many years, Mark? Like the longest data warehouse project you've been on?
That I've been on?
Yeah.
Well, I mean, I'm aware of projects that never end.
That never end. Okay. But it's a project. So a data product takes a very different approach, and that's a product management approach. I have been to these clients who, like the CFO, comes to work and looks at the dashboard, suspects there's a problem, and that's a data observability issue. But so the CFO says these numbers are not correct. Who is the person responsible for that? There isn't a single person. because it could be a data engineering problem, maybe a pipeline did not run, it could be an upstream problem with bad data. So there is this complete confusion. So what happens is that all hell breaks loose. Everybody goes into this firefighting mode, trying to decipher and do this root cause analysis. So in data product, the main problem we are solving is the problem of accountability. There is an owner who is responsible, has published the data quality, the KPIs, the attributes, the schema of that data product. So first rule, a data product is always business driven. It's not a data engineering, data warehouse problem that the data engineer is trying to figure out what does a business want. So that's number one. Second thing is it is built using product management principles, which are not new. They're new to data. But in software engineering, we've been applying the agile practices, DevOps, for more than 10 years now. Now we are bringing that product management discipline into the data, and that's what is a data product. Now, let's move to technical. So what is a data product technically? It is nothing different than what you do today. It could be a materialized view. It could be a data mart. It could be a machine learning model. It could be a report, a dashboard. The only difference is that we have sort of decentralized it. We have given this ability to the domains who know the data the best. For example, Modak, the company that you started, is very big in the healthcare space. So if I'm a data engineer, if I see healthcare data and somebody tells me, I want you to combine this and do this and do these reports, I don't understand anything about the context of that data because I'm a techie. I am not a healthcare expert, but the business does. So if you take some of these data engineering capabilities and move them to the domain, have them build out the artifact and put the stamp on it, that's a data product. So a data fabric makes it easy for the business team because you have to remember that it's a mindset shift. It's a data culture shift because we are going from a centralized data team to this distributed domain-driven piece. Domains may come back and fight us and say, well, I've never had to do this IT stuff. What do you mean that I now own it? So we need to make it easy. And this is the reason why data fabric comes in, because domain people are not software engineers, they're not data engineers, but we're asking them to do this. Why are we asking them to do this? Is because we have a huge problem. The problem is very simple. Data is a victim of its own success. Everybody wants access to data. We have more data consumers, we have more use cases, we are producing more data, we have more data sources. So the data engineering team is getting squeezed in between. So by moving to this decentralized approach, we can alleviate this problem, create a data product, make that data product discoverable in a catalog, and then so then what happens? So I'll give you a practical example. Let's say I'm in marketing department, and it's my job to come up with who are our customers, prospects, and so on. So because I'm in marketing, I have access to Salesforce, where my prospects are. I have access to Oracle, where the transactions are. I have access to Marketo. I have HubSpot for the conferences that I do. I have surveys from Qualtrics. I have clickstream data. So I've got all of this data. So what I do is I write my SQL, I write my procedures, and I create a product on these are my customers. So I publish it and I version control it. I say, this is version 1.0 of a data product. What a concept. Software, you always have versions. In data, have you ever seen a version? But in data product, you do have a version. So now I published version 1.0. Sales department says that we want to run a machine learning model and calculate customer churn. But customer churn on who? Who are our customers? So they go to the data products catalog and they say, oh, look, marketing department has published a data product 1.0 on the official set of customers. So I'm going to take that data product, I'm going to apply my NPS score and whatever things I have in sale, and I'm going to predict which customers can churn. And they will create their own data product. So now you see there's a derived data product. Tomorrow, I may buy yet another system in marketing department, and I may enhance that data product. So now I have version 2, backward compatible. So now the salespeople can say, oh, look, I have more advanced data about marketing. I'm going to take that, and I'm going to create my own, a new version of data product. It's all audited, it's all in the catalog, it's all curated, and you can discover it. So this is the power of data products. What happens is a lot of companies I talk to, they like banks and all, every 6 months they would have a new product. Now they're doing it in every 6 weeks. And there are 3 of you from Accenture here. So Accenture is actually at the forefront of creating data products. There's a whole team that is doing data products. So I hope this helps. So with that, I am going to go to the slide that I told you I have on unified. Please go ahead.
Yeah. So why do you need the unified metadata for all these capabilities to work? And that's a good question. So a lot of times when we get questions from our people who we build data products for, the first thing is, when was this refreshed? When did this pipeline run? I see a data quality problem. How do I go fix it? Or just the fact that, can I get a business glossary of this thing? So what we are talking about when we have all these capabilities of data fabric is bringing all this technical metadata, business metadata, then operational metadata, which is when did this pipeline run, how long did it run, who ran it, who has access to it, so all of that operational metadata. And then people forget one of the most important metadata is the tribal metadata. And we also aim to capture that. What I mean by tribal metadata is, if you look at teams building data products, they build for like 3 months, they move away to something else. All that information while they're building this data products is lost. So how do you capture that and store those? So if somebody else is looking at a product, building a similar product, or they're looking at that particular data product, they can go back, oh, this product was built like this. This is the tribal knowledge which I have. So you need to capture all these particular metadata into a metadata repository and then expose it to everyone who wants it. Like, I didn't realize how critical it was for our R&D scientist of one of our top 5 pharma companies we work with, is they just needed, hey, I have updated this. I want to know where exactly is it in my life cycle of when this will be refreshed. So now I have all these operational metadata just sitting in different data silos by itself, but not exposed to the person who is using it, saying that, hey, you updated this, it will take another 24 hours by it will come, or 6 hours, so whatever that metric is. So the important thing is, whatever we are doing here for different capabilities of the data fabric, you need to have a unified metadata, what I call plane, which allows you to expose all this and then disseminate that information to whoever wants it.
See, this is really interesting because we've talked about data silos, but if we don't do this, then we'll have metadata silos.
Exactly.
Which is kind of a new concept, right? It's like, so in fact, metadata is so interesting because I talked about data products. So not only can you discover all the metadata about data products, but you can start capturing the usage of data products.
Yes.
How many data products were built? How often? What is the release cycle of data products? How many people are using it? You can discover based on the usage statistics, how important is that data product? If you find out, for example, that a data product has not been used for, let's say, 18 months, that's a warning signal. You should retire that data product, right? Because that product could be a machine learning model. And this, by the way, is an actual use case. I'm not making this up. I have a client who migrated into the cloud everything, and then they had these machine learning models that were not updated or trained for 18 months. If somebody runs that machine learning model, they're going to get wrong results. So with the data products, you can actually do all of this. In fact, you can now, for the first time, start measuring what is the developer productivity by counting the number of data products, how often they were released, and release cadence, and all of that.
Sure.
Great. All right. So with this, let's change tracks here, and I can give you the clicker. You can talk about Nabu.
Yep, sure. So how do we enable all this, right? And so if you look at the sources, you have both structured, semi-structured files, and files is becoming more and more important, especially in the areas we deal with, and more with generative AI. So you have your documents spread across your Documentum or SharePoint or whatever it is. You have structured data, semi-structured data, even events and real-time stuff. So what we do is, at Nabu, we first have what we call data spiders, which go and crawl all the technical metadata and suck them out from dictionary tables or your file systems, telling that this file exists here, this file exists here, be it even cloud applications like Salesforce or Viva Vault or whatever those are. You basically go and capture all the technical metadata and suck them out of the system. Once we do that, we have all of that information in something called our repository, which is called Kosh, and we store all the technical metadata there. And then once we have that, we kind of plug into whatever data platform you have. It's like cloud agnostic, so you might have Databricks, you might have Cloudera, you might have AWS native, you might have Dataproc, whatever that modern data platform you're building. Then we start using that platform to move your data. Since we know what the data at the source is, if you want to move the data and profile it or look at it or understand it, we bring that up. Beyond that, there is a capability to profile that data. Why do you want to profile that data? You want to know any data quality issues. You want to understand what elements are. So example, we have a ML-driven approach where we can find out if this is a customer ID. The customer ID could be just ID, cust ID, customer, whatever it is. The column name might be different. It goes and figures out all the different elements and starts tagging those, saying that this is customer ID, this is product ID, this is my sensitive information, this is GDPR sensitive, this is PII. So all those things which you need for enterprise, which regularly happens, we automate that for you. And again, there is a human in the loop, so it doesn't mean that I am automating and this is it. You can govern how you do it, but we start tagging those things for you. Once we have that, we basically allow you to build a knowledge graph, which allows you to search which data set is what. So if you want to go and say, hey, tell me about this product, I want to know all the data sets which this product belongs to, it will list all those products and start allowing you for a discovery of those data sets. So you are accelerated, spending a lot of time in figuring out where my data lies. This knowledge graph will start answering those questions for you. Not just that, it will also give you things like, hey, this sales data is related to this marketing data. This product information is related to this product master. So all of those capabilities are inbuilt, and it does that. And then we have features which allow you to prepare the data, work in a collaborative environment called workspaces. And then you start, the data domain teams start picking up that, like almost I call commercial kitchen approach data, where it's like laid out for you and has all that in sorted order. And then you start creating your data domains and data products. So what did we do from a fabric perspective? Lot of the things which are repetitive, whether it's like change data capture, or whether it's figuring out how to ingest a JSON data set, or figuring out how to extract a text from a document, or ingest data from Oracle, land it in, let's say, in object store on S3 or Azure or Databricks or whatever it is. It allows that seamless integration between different sources and destinations. Again, to reiterate that, what we are saying is 70% of the task, according to, and this is we working with some of the largest enterprises in pharma and life sciences, and healthcare space. What we found out of that is 70% of your heavy lifting can be automated. So, like again, automated generation of ingestion pipeline, discovery of data, building observability rules. So example, today my data has schema drifted, and nobody knows what it is. So send an alert that, hey, for this product, this schema has drifted, or this quality rules have failed in this particular product, or this pipeline, which was supposed to run in 1 hour, took 3 hours. Should anybody care? The volume I see in like 1 million now is like 10 million. So all these data observability and data quality rules are pre-baked for you within how you build that, so that you can monitor them and efficiently execute those kind of things. So what we are saying is 70% of this thing would be automated and 30% of it would be augmented. So how do we augment it? Because we profile the data, we tell this data set is related to this data set. These are the fields which you need to think about. And now with LLM and generative capabilities, we are looking at the next step where we can even generate SQL on top of having all this information there. Now I'll hand it to Mayank.
Thanks, Milind. Thanks, Sanjeev, for laying out the context behind Data Fabric. We started with a poll that talked about roughly 50% folks researching Data Fabric. And the good news is that we've seen some very tangible outcomes with some of the customers that we've worked with. We'll talk about a few of those. In life sciences, we worked with one customer where they are converging data from across multiple different sources. And compared to some of the traditional methodologies, Data Fabric implementation has resulted in about 40% reduction in costs. Again, this is something that is implemented at scale. So we are looking at data being pulled from 200 plus different data sources, data at the scale of multiples of terabytes, and something that impacts real business outcomes for this customer. We'll drill deep into this particular example, but there are others like this. In the healthcare space, we worked with one customer which has migrated away from a legacy platform onto a platform implementing some of the Data Fabric principles. Again, this is a migration done at scale involving more than 1,100 different pipelines. And it has resulted in some significant cost savings as well as acceleration in time to value for this customer. It also opens up some new possibilities once data gets integrated, once data is available for a variety of use cases to the right stakeholders. It opens up possibilities for implementing some new use cases such as interoperability using some industry standards, and how do they collaborate with their larger ecosystem. There's one more example that we know of. Again, one more customer that we worked with, large-scale pharma customer, where they have implemented a huge data lake using some of the Data Fabric principles, running into petabytes of scale. So these are just some of the examples where we've seen the implementations impacting some of the business outcomes, and something that gives us the direction in terms of how to think about, how to go about implementations of Data Fabric. I'll go a little deeper into one of the case studies, and the reason why we like this is that this comes from life sciences. And life sciences, as we are aware, drug discovery is one of the core business functions for any life sciences company. And typically, a drug discovery process can go into about 10 to 12 years with about a couple of $1 billion of investments. So the opportunity to optimize this are huge. And increasingly, drug discovery is driven by data and analytics. The ability to harness information from different sources, the ability to make connections, understand relationships that exist between different entities such as molecules, drugs, genes, adverse effects, and so on. And having that information available to the right stakeholders is what can significantly impact the outcome of a drug discovery process. And this customer that we work with utilized some of the Data Fabric principles in terms of building out a framework for running these pipelines using the metadata-driven approaches that we talked about, preparing that data so that it is now available for the end users to look at, to explore this data, see the associations in terms of a knowledge graph, and thereby being able to harness the real value that exists in data for their business outcomes. This is one example which has been recognized in some of the industry forums in terms of awards. And as of now, this is a platform that provides the data products which are used by more than 5,000 users. So in terms of scale, in terms of the impact, in terms of how tangible business outcomes are influenced, this is one good example of how data fabric implementations have really accelerated that process of reducing the time to value as well as optimizing for any operational efficiencies. We talked about the time to value. We looked at the implementation, and this has brought down the implementation time from about 12 months to 3 months. So significant improvement, significant acceleration, 4x acceleration in the time to implement a data platform, which is working at a scale of more than 200 sources, multiple terabytes of data, and something that is now available for hundreds and thousands of scientists to look at, to be able to use it for their daily research. And some of these associations that they've been able to draw relate to, and these are very specific to pharma, but things such as understanding drug and drug interactions, for example, or understanding the relationship between drugs and the adverse events. Looking at data from, let's say, the real world evidence that comes in from usage of drugs, correlating that with some of the existing scientific research that might be available, and then being able to draw out those knowledge graphs that explain these relationships and inform their research as they go along. With that, we'll talk about and we'll demonstrate how some of these things are implemented. Milind spoke about the architecture of what Modak Nabu brings. We looked at some of the case studies of how these have been influenced or how the business outcomes have been impacted. And we look at how Modak Nabu helps to accelerate this entire process. And essentially, when we look at this demonstration, we look at the low-code approaches for data integration, how using a metadata-driven approach, data integration process can be significantly accelerated. We look at collaborative environments for preparing data for various end use cases. Once data is prepared, the quality of that data impacts the usability. So the ability to monitor the quality of data as it is getting prepared is significant and is an important driver of influencing the usage of these data products, as well as finally the data cataloging and discovery. So how those data products can then be discovered by various end users, explored by them using some of the no-code approaches, and how that democratizes the entire data and analytics process. So we'll play a small video, and with that we will cover some of the key capabilities here.
Modak Nabu is an integrated data engineering platform that enables creation of enterprise-wide data fabrics. Modak Nabu has an amalgamation of different capabilities such as data integration, data preparation and curation, data orchestration, as well as data discovery that enables implementation of data fabric and helps organizations accelerate the pace of creation of data products for a variety of use cases. As a first step, the different sources of data that exist in an enterprises are added as data connections into Nabu. When these sources are added as data connections, data spiders, which are essentially metadata crawlers, connect to these sources and get the metadata from these sources, which is captured in the metadata repository of Nabu. These spiders can be scheduled to run at a regular frequency so that the metadata in the repositories is kept fresh at all times. Out of the box, there are about 35 different connectors available for sources such as containing structured data, semi-structured data, unstructured data, data on-prem, data on cloud. So for a variety of use cases, these connectors are available out of the box so that the metadata from these sources can be captured in the metadata repository of Nabu, which is then used to create pipelines for bulk ingestion using a no-code approach. So once the data sources have been crawled and have been added into Nabu, we use the no-code approach to create the pipelines to bring in the data from the different sources into a data lake or a data warehouse. Provide some of the identifying information for the pipeline, select the sources from where we need to bring in the data, And this could include specific tables in case we want to bring them, or exclude certain tables or files which may not be required. Select the destination where we want to land the data, and then configure that data movement in terms of a compute engine that will be used to execute this data movement. Nabu uses Spark for carrying out the computation for data ingestion and data curation jobs, and a variety of different Spark environments can be added as compute engines in Nabu, which can then be used for running the pipelines. To handle a variety of different scenarios, Nabu provides various advanced options that can be configured using the UI. These could include things such as handling schema drifts or managing any kind of inconsistent data types that might exist between the source and destination. At a table level, there is further level of granularity that is available in terms of the control that can be exercised. This could mean in terms of, for a particular table, which columns should be ingested or how they should be casted, or even handling scenarios such as incremental load of data or slowly changing dimensions to be created at the destination. Once we've selected the options, selected the tables from the source, identified the target where we need to land it, configure the data movement in terms of the compute engine to be used, set any kind of advanced options, we can then schedule the pipeline to run at a regular frequency or run it at once, and then the data will be ingested in bulk from the identified source to the target using the configuration provided and applying any kind of different advanced options. As a next step, the data can then be transformed for a variety of use cases, and which is where Nabu provides a collaborative work environment in the form of a workspace, where different users from different cross-functional teams can come together to create these pipelines using a no-code approach, discuss the transformations required, execute it, and monitor it from the same environment. An example of a data transformation would look something like this, where data has been, once it has landed, there are various kind of transformations that are being applied, and then the final output is being created. There are different options available for processing of this data, to include operations such as join, split, aggregate, that could be used for transforming the data from a different types of sources to different destinations. While these pipelines are being created, Nabu also provides the ability to check for the quality as the data is being prepared. There are a variety of different rules that are available that can be applied for these pipelines. These could include things such as checking for not null or unique constraints, or checking data types or length of data, and so on. There is flexibility around using custom SQL as well for creating these data quality rules, so that business specific data quality rules can be applied as part of these pipelines. When these pipeline runs, there is functionality available to observe any kind of changes which might be relevant for creation of the data products. This could range from identifying schema drift, or understanding if there are any duplicate records detected at the source, if there has been any data change, or if there has been a change in the number of rows at the source. Those kind of alerts can get triggered once they are enabled, and enable users who are creating these pipelines to take action early based on the alert that has been triggered. With the data getting curated, it is now available for a variety of different scenarios, and typically in an enterprise, what we see is that the final outcome that can be consumed comprises multiple different steps that need to be executed in synchronization for a final output to be created. And to be able to create that kind of a flow from source all the way to the destination where the final product is available, Nabu has a feature called the Data Flow Studio, which allows these flows to be created using a no-code approach. In this particular example, we see that data from a variety of different sources, from an FTP connection, from an HTTP connection, from an internal Oracle source, those have been crawled in the first step. Then the data has been written to a data lake. Then there is some curation that has happened in a workspace, like the example we just saw, and then written to a graph database, after which some data quality rules have been checked. And at the end of the pipeline, a notification has been triggered to notify all the different stakeholders. So this kind of a data flow can be created again using the Data Flow Studio, which provides various options to put these tasks together to execute an order in an event-driven manner. So we could, for example, set a condition for execution of a task that it executes only once the previous task is successful, or in this case, an ingestion pipeline can run only if a new or modified object has been found at the source. So various options to trigger these flows in an event-driven manner, in a synchronized manner, that ensures that these flows can run consistently and produce an output predictably for various use cases once the individual components have been created with Nabu. A lot of enterprise use cases require operations to be performed on a large number of files, and which is where Nabu also provides a capability called File Ops to use a no-code approach for running these operations at scale. These operations could include activities such as decompression of files, conversion from one format to another, encryption, decryption, merging of different files, and all of these can be orchestrated using the no-code approach at scale across a large number of different sources using the File Ops functionality. The various operations required for creation of data products, such as data crawling, pipelines for ingestion and curation, data flows, all of those can be monitored through an integrated dashboard that provides an update on the status of individual tasks, as well as provides information that is relevant for troubleshooting any errors that might exist. So users can look at a granular level the status of individual activities. They also have access to the logs, which helps in identifying the reasons for any kind of errors that may have arisen. Once the data products have been created, they can be explored using the data discovery functionality. And to enable that, we start with creating data domains. Data domains in Nabu are access governed logical groupings of data assets from one or more different physical sources. To create these data domains, we select the tables or views from a variety of different sources that should be part of this data domain according to the business context. We schedule profiling and indexing on these data domains to run so that the data is searchable and explorable for end users. And as once the data has been profiled and indexed, different users who have access to data assets within a data domain can start searching for it using the search interface. They would see various results that match the keyword that they have entered, and within a data domain they can look at all the various data assets that exist. For a particular data asset, users have access to the metadata from that. For that table or data asset, they can look at a detailed profile that helps them understand what kind of data might be there. Parameters like null count, distinct count are available. Maximum, minimum values, most frequently occurring values that help users to understand what type of data might be existing and whether it is relevant for their use cases. Using data domains, users are also able to understand any kind of business context that is attached to the data in the form of various tags. So example, if they look at a data set which shows different tags that are available, these tags are auto-propagated using Nabu's data fingerprinting technology, and these tags provide a business context for users to understand what type of data might be there and what is the significance of that data. For example, this could be used to identify sensitive data, PII data, and so on. These tags are propagated using the data catalog functionality in Nabu, where we create entities. For creation of these entities, users identify column, which is referred to as a fingerprinting column, and provide.
I think we covered a lot of ground around it, but hopefully this would have given some context around what a typical data implementations look like, how can they be implemented. We looked at some case studies and what are the business outcomes that they have delivered. To summarize, I think just a few key points. Data fabric as an emerging data management design. We talked about most people researching this. Hopefully this gives a flavor of how this can be implemented and how this can be used for enhancing productivity for various teams. I'll pause here and we'll take any questions. We'll open it up for Q&A now.
Any questions from in the room? No? We had one online. In your view, what are the main challenges for the implementation of a data fabric?
One of the key challenges that we found is more around aligning with the business priorities. I think the typical approach that we've seen sometimes starts with looking at the technology and trying to see what is possible through that technology. But I think there's a need for looking at what is the outcome that needs to be delivered, and therefore what is the technology that is required to support that outcome. And which is where principles such as data fabric really come in place. Because what we are seeing is that you have a unified business outcome to deliver, and therefore to try and deliver that, there is need for an integrated approach. How do we combine different tooling to work together to deliver that one outcome predictably in a way that can be used, reused across multiple different data domains. So I think just aligning with those business priorities and then working backwards to figure out what is the technology that supports that outcome is one of the key challenges. And just getting that alignment in place is something that is worth investing time and effort on.
Thank you. And one more. We know that a lot of the new modern data environments include files, more so than relational databases. And so what's your experience in converging data from different file stores and different formats and creating that data fabric over top of it?
Yeah, and that's a great question, because this has been our experience as well, that a lot of enterprises use multiple different files which are residing in different file formats. And again, files represent their own kind of different challenges in terms of how the data is available. So pulling in data from different file stores which are in different file formats and then processing them through so that they can be, the data within them can be used as part of a finished data product is one of the key opportunities that we see. And what our observation has been is that when we come to file processing, if we really break down that problem, we are really looking at some common operations being performed across scale. And these operations are more around how do we convert file from one format to another so that it can be consumed in a different system, or how do we compress or decompress files, or maybe how do we encrypt or decrypt it, or how do we merge different files. And the real challenge really comes when we have multiplicity of these different file formats, and we are trying to do this at a scale of millions of files, which is where some of the no-code approaches around how do we configure these processing to happen across different file stores and across different file formats is something which is useful in accelerating the overall velocity. Because otherwise, files by itself, even though these individual operations might seem trivial, given the fact that these have to be performed at a large enough scale, have to be performed repetitively, they can represent one important part of the time that it takes to create that final outcome. So no-code approaches, low-code approaches, which is actually one of the motivations behind file ops that we briefly saw during the demo, is how do you enable users to be able to configure those pipelines and run them at scale for a variety of different file formats, for files originating from multiple different formats, different file stores, and run these very common operations using a drag and drop no-code approach. So that's really been our experience, that how much we can abstract away the complexity and present it in the form of a no-code approach. That is what really speeds up the file processing.
Thank you, Mayank, Milind, and Sanjeev. We now have a 15-minute break until the next session. So thank you very much.